Hi, in this video, we are going to understand more about ARM architecture. So what is ARM architecture and how exactly it can be used? Let's try to understand in this particular video. So before understanding more about ARM architecture, let us try to understand what are the other architectures that are available and how various companies will make their own processors. All right, let's get started. So if you look at the companies like Intel and AMD, they use x86 based CISC architectures, complex instruction set computer architectures to make their own processors like Intel Core i3 or Core i5 or Core i7 and similarly AMD Ryzen series processors. All right. But if you look at the other companies like Apple, Qualcomm and Samsung, they make the processor SoCs which are going to be used in mobile platforms. So these processors are going to be based on RISC architectures, reduced instruction set computer architectures. So ARM processors are based on this particular RISC architectures. All right. Now let's look into ARM architecture in detail. In the later part of this video, we will try to understand more about the different kinds of ARM architectures that are available and how exactly ARM company operates. We will try to understand all of them in the later part of this video. All right. Let's move on. This is Maven Silicon confidential note. Whatever the material that was shared with you as a part of this training course are proprietary material of Maven Silicon, and please do not misuse them without proper approval from Maven Silicon. All right. Okay. Coming to ARM. ARM is a company that has been founded in November 1990 and its headquarters is in Cambridge, UK. So ARM stands for Advanced Risk Machines. So as I have told you people earlier, ARM architectures are based on RISC architectures, reduced instruction set computer architectures. And what is ARM famous for? ARM is famous for its wide range of RISC processor cores. So all the companies like Apple, Qualcomm, Samsung, or any other company which makes their own microcontroller boards like Raspberry Pi, they make their own processors by taking ARM processor core as the main IP. And along with the main processor core IP, which is purchased from ARM, these companies will add other peripheral blocks, and that's how these companies will make custom processors. But internally, all these processors will contain ARM processor core. So ARM is famous for developing processor-based IPs. Of course, those IPs can be physical IPs also, so that you can directly use them while doing floor planning and placements in the IC design process. So one thing that you need to know about ARM is ARM doesn't develop any chips on their own. ARM doesn't really make any processors on their own. ARM just provides IP. By using those IPs, other companies will make their own processors. So ARM can be considered as a fabless IP company. All right. Now coming to the applications where ARM processors can be used. So we have different kinds of ARM processor cores which are suitable for meeting the requirements of huge range of applications. You can take a laptop or a high-end server. So there are different set of ARM processor cores which are suitable for those kind of high-end applications. And similarly, if you take a simple timer or a simple embedded application like a treadmill or a washing machine or a microwave oven, even for those kind of small embedded applications also, ARM processor cores are available to meet the requirement of that particular specific application. In that way, ARM processors have got huge range of applications which are suitable for mid-range, low-end and high-end applications as well. All right. So in the later part of the slides, we are going to understand when to use which kind of profile or when to use which kind of processor from ARM. All right. Let's look into one simple case study. So if you look at the case study of ARM processor, which is Cortex A53 processor, this Cortex A53 processor has been launched by ARM in 2012. And after that, most of the semiconductor companies like Qualcomm, Samsung, MediaTek, and NXP, they tried developing their own processors by using ARM Cortex A53, and it has been a massive success. So ARM Cortex A53 has been used in huge range of applications, being gaming or smart gadgets or even mobile phones or even embedded applications everywhere. This ARM processor Cortex A53 core has been used and it has got huge range of success, a massive success. All right. Now let's look into the products from ARM. So when it comes to ARM as a company, it develops huge range of products to meet the requirements of various applications. ARM has developed various kinds of products. So all these products are categorized into different families. All these products are categorized into different families. For example, if you look at Cortex A, Cortex R, and Cortex M, these three are the families which contain processor cores which can be used in different kinds of applications. For example, if it is a small embedded application where a simple microcontroller is good enough, you can choose a processor core from Cortex M. Cortex M stands for microcontrollers, right? Similarly, if you wanted to build a complex processor, something like a processor that is going to be used in a mobile phone, that kind of processor has to run a complex operating system such as Android, right? That's where you can choose the processor core from Cortex A as well as Cortex X. So these two are a kind of high-end processors so that they can be used to run complex operating systems such as Linux and Android or even iOS, right? And for the real-time applications, something like Wi-Fi routers or hard disk controllers or memory controllers where they need to deal with huge data, huge volume of data, then Cortex R processors can be used to process the data in the real time, right? And similarly, for 5G and complex servers, right? You can prefer the processor cores from Arm Neoverse category. Similarly, for gaming and image processings, we have Immortalis and Mali ISP. Similarly, for graphics units, we have Mali GPU. And for artificial intelligence and machine learning, we have Ethos Neural Processing Unit, right? Now, in 2024, ARM is focusing more on developing processor cores for artificial intelligence based applications, right? This is highly needed for existence in the market. Otherwise, ARM is facing very tough competition from NVIDIA. So this year, ARM is focusing more on developing processor cores for AI based applications. Similarly, as I have told you earlier, all the companies like Apple, Qualcomm, and Samsung, they make their own SoCs by taking ARM processor cores along with some other subblocks. But how do we interconnect the processor core from ARM and other subblocks from third-party companies? How do you interconnect them? To interconnect them, we need proper interfaces, right? Some standard protocols are needed. That's where ARM is proposing some standard designs, which will come under core link, which will help us to establish the interconnections between various subblocks. All right. And the companies like Apple or Qualcomm, when they are making multi-core processor, something like 8-core processor or 16-core processor, they can take a combination of all these processors, right? So that they can achieve both performance as well as they can reduce power consumption. So if you look at a case study, right, Samsung Exynos 2100 processor, it's an octa-core processor. So it contains one number of Cortex X series processor to give high performance and three number of Cortex A78 processors and four number of Cortex A55 processor. And along with that, it contains ARM Mali graphic processing unit as well. So that is how the Samsung Exynos 2100 processor has been made by taking processor cores from ARM, different kinds of processor cores from ARM. All right. That's all for now. We'll meet in the next video.